This is video number 2 for quiz number 2, where we left off on the first video for quiz 2. We were at this point right here. We found that power was going to terminal 8 here on plug J4. And when we looked at the terminology for that, J48 was 120 volt power to the power of the UV, and I told you that was an ultraviolet scanner. So let's go back and look at the terminology page. And as we scroll down here, you'll see here, this is the pictures of the Honeywell ultraviolet scanner. You've probably seen these on boilers before if you looked close enough. It actually sees ultraviolet radiation. Right here it says that the what they call mini peeper is an ultraviolet flame detector that detects the ultraviolet radiation emitted by combustion flames, and that's how how the controller knows that there's actually flame there. And on almost all boilers or burners, you can actually measure the flame signal that this is actually seeing, and you can on this, and we'll get to that when we look at features of the touchscreen display. You can actually see the flame response, flame signal, and the strength. One thing I skipped over here, I want to get back to this proof of closure thing that we talked about in the first video. Here are the gas valves. This gas valve here is the secondary gas valve. When you see the actuators stacked on the gas valve body, there's actually two actuators. This is an on-off actuator without proof of closure. You don't see the terminals there, but this is an on-off actuator. Here's the power H and L, but you also have terminals 5 and 6, and that is your proof of closure. That's the switch inside there. So on the first gas valve, there is a proof of closure switch to make sure that the valve didn't get stuck. Primarily or typically on the secondary gas valve, you don't have to have the proof of closure switch. So going back to the diagram, on sheet 2, page 2 of the diagram, which is the right hand half of the diagram we've been working with, here's where you'll see connector J1 and terminals 4 and 6. This is where the actual scanner that you just looked at actually plugs in. There's the UV scanner. So getting back to our diagram here, now that we know power going in on J48 is for the ultraviolet scanner, we assume that since they wired that this boiler is using an ultraviolet scanner, and we did prove that by looking at the right hand sheet of the wiring diagram, and you saw where the ultraviolet scanner plugs into. While we're here, let's take a look right now at these 4 terminals here. This is field connected things that you would add to the boiler as field connected devices. One is a combustion air damper, CAD. CAD stands for combustion air damper, and then they have the term fan. So, you know, a lot of times on boiler rooms nowadays, instead of just having a louver on the wall for combustion air to supplement for the air that is going up the stack, air to get in the boiler room, now a lot of times it's done with a makeup air fan. So regardless, this is a contact point, and again, we'll talk about the term dry contact. There is no voltage on 40 and 41, but internally in the controller here, there is a contact that will close when it's time for the combustion air damper to open or when it's time to start the fan. And here is a connection between 42 and 43. These are boiler terminals that you can connect a booster fan. Booster fan, you know, another term for and in this case, booster fan means an exhaust booster or a flue exhaust fan. And that comes down to terminals 3 and 2, and the combustion air damper was 4 and 5. So let's go back to the Honeywell page for those for those terminals. And you'll see here that J42 and J43 is called pump C input output, and J45 and 4 are pump B input output. Actually, what that is a dry contact that typically would be used to turn a pump on and off. When they say input and output, I don't know that you can really call one side the input, one side the output, but they're doing that. You bring power in on J43, and when in the sequence, when it tells this device to turn on, which in our case is going to be the booster fan, it makes contact between 2 and 3. So they're saying J42 is the out. But here's the important thing. The contact, this is considered a dry contact, and you can run up to 120 volts at 44 locked rotor amps or 7.4 run amps. And when you see the term amps, locked rotor, and amps, you think a motor. And yeah, you could directly connect a fan motor that had a full load amps of 7.4 directly to these contacts and stop and start it through that contact. Typically, that's not what you're going to see on a booster fan or combustion air damper. You would probably just run voltage through the contact, and then you would use a relay or a motor starter to turn something else on and off. But what you're seeing here is that with the 3 dry contact points that they provide for pump control, and these are programmable, you can actually go into the configuration and change how these contacts operate, or in what sequence they operate. But you cannot connect anything that has a run amps of greater than 7.4. You can't connect anything with a voltage over 120 volts AC, and they give you a locked rotor amps. Here's the bad thing. If you ruin one of these contacts because you put too much current through it or something shorted out, you're not going to replace that. You're not going to repair it. You're going to have to replace the whole controller. So it's probably better to consider these as light duty or pilot duty, and don't try to run higher amperage equipment through them. All right, getting back to the drawing. There we go. So now I think we've covered pretty much everything that's connected to J4. We have our neutral, we have our ground, we have the power going in here for the UV, and then we have our switch connections here for the combustion air damper and the booster fan. Going on down, here's the power on lamp, which is a clear lamp. Just means that we've got the power turned on. Obviously, if we have power on terminal 3, we've turned on the switch, control switch there. So we'll scroll down to the next screenshot here, and then we get to this part here, MR probe LWCO. Okay, important to know exactly what this means and what it's telling you. MR stands for manual reset, probe LWCO. LWCO is low water cutoff, and it's a probe type low water cutoff. So if we go to the terminology page and you scroll down here, you'll see McDonnell-Miller low water cutoff. This is a picture of it. It has a test and reset button. It has indicator lights for when power's on, and a red indicator if it's tripped or it's not seeing water. You look down here. Here is the probe. The probe has a ceramic cover. It's a brass nut, and what that probe is looking for is conductivity to ground. So it's looking for water to create a conductive path to ground so that it knows there is water present, and that's what a probe type low water cutoff looks for. When you mount the actual controller on the probe, which is typically the way you'll see this, and it can be remote mount, but you'll see the probe will actually stick through this hole. You hook up the little eyelet there to the wing nut, and through the electronics here, and here's your terminal strip, it will determine whether or not there is conductivity through the water to the ground point, which is the actual base here. And one of the things that's very important, now that you know that conductivity to ground, you have to make sure that the casing of this box is securely mounted to this brass hex plug here, because if it's not, you're not going to get a good ground reference. So if you take the box off or it's loose on there, that could give you problems. But that is the probe type low water cutoff. Anytime you see the initials LWCO, you should think low water cutoff. When it says probe type electronic, that's exactly what you're looking for. Okay, so back to the wiring diagram. Here you see power coming in to terminal 1 or H, and I know they give dual designation for all these terminals because there are two different brands or manufacturers, brands of low water cutoffs that they use. Some of the manufacturers, this terminal here is called H, some of them it's called 1. So that's where you see the 1 over the H, 2 over the N. This is either neutral or terminal 2. On this, you do have to put power to the low water cutoff. It's an electronic device. It needs 120 volt power to operate. So you get power to it, and then you have a jumper here that goes from 1 to P1 or C, could be called common. So we have 120 volt power coming from 3 going here to power the electronics, and then coming down here to the switch common. And then if it's closed, which is normally closed there, we would get an alarm. And the reason that it's shown as the alarm is the normal position is because if there's no water, that is the normal position. Once it detects water, it will open this contact and close this contact. Then when it closes this contact, you get power through here to terminal number 4. And we'll look at the 2 points that terminal number 4 goes to. One is to the thermal fuse here, but it also goes down here, and I'm going to have to scroll down to the next page, and you'll see where it comes down from 4, and it comes down to this terminal J62, which is called low water A1. And this is kind of important. You may wonder why there's no wire hooked up on the alarm terminal. Wouldn't you want to know when the low water cutoff is an alarm? Obviously you would. There's a red LED on the low water cutoff, but with the door closed, you're not going to be able to see that. So how would you know that it's an alarm? Well, through the inputs, and that's what you're looking at here on J6 and J7 of the controller. Through these inputs, it can monitor whether or not a device up here, thermal fuse, as we follow through, you'll see it can actually monitor that and give you the information on the touchscreen display whether that device is in alarm or if it's still in its normal state. All right, I got about a minute and a half left on this video, so when I want to take a look at that terminal that the low water cutoff was tied into, and there we go. It's J62. So when we look at J6 terminal number 2, it is enunciate 1, and it can be either 24 volts or 120 volts up to 2 milliamps maximum. Really, it's just a power going to that terminal, and that input, you can see you've got enunciate 2, 3, 4, 5, 6, 7, 8. Those enunciation inputs are what the controller uses to determine whether or not that control is either closed or open.